Hi guys, welcome to another exciting video on Java tutorials. In the previous video we talked about something called as hash tables, stacks, vectors and so on. But today we're going to talk about another class called as hash maps. It's similar to hash tables with couple of differences. So I will see you on the other side guys. Alright guys, as you can see on the screen, we have something called as a map interface. Under a map interface, we have something called as hash table, we have something called as a hash map, under which we have linked hash map, and then we also have a class called as tree maps. So we have already looked at something called as hash tables, but we're going to look at something called as hash maps today. There's only mainly basically two big differences guys. One is that hash tables do not have any null values, they do not have any null keys. But when you talk about a hash map, it can contain one single null key and it can contain multiple null values. That is one big difference. Another difference is that your hash tables are synchronized, whereas your hash maps are not synchronized. Now, what do you mean by synchronization? What do you, what is the difference between hash table and hash maps? We will continue with the next slide. I will tell you in detail in the next slide, guys. Alright, so the first point you can see here is that the class name that is used for your hash maps is hash map, right? It's very similar to your hash tables. The underlying data structure which is used by hash maps is also hash table itself, right? The second point is that the insertion order is not preserved, right? The reason is because we have something called as key and a value. So just like your hash tables, your hash maps are stored in terms of keys and values. Every key will have an equivalent value to it, right? So that is the reason the order of, it is not preserved the way it is inserted into the table. So that is the second point guys. And the third point, I will tell you what that hash code for a key means with a diagram a little later. But we will continue with this particular slide and I'll come back to that diagram a little later. The third point is that duplicate keys are not allowed guys. Yes, you can have duplicate keys in the sense that if you have a key with the same name, then the value will get replaced at that particular key, right? That is what it means. The values can be duplicated as many times as you want for each of the different keys guys. Fourth point, we can have heterogeneous values. I can store an integer value, I can store a string value, I can store a float value, I can store whatever type of value I want. That is what heterogeneous means. So I can have a heterogeneous key as well as value. Next, I have already talked about hash maps can have only one null key and it can have multiple null values. Next, hash maps are not thread safe. Now, what does this thread safe actually means? Remember, when we talk about threads, there are multiple threads running at the same time trying to access a particular thing. So, in this case, when I talk about a hash table, if multiple threads are accessing a hash table, it will be synchronized. That means one thread will get access to that particular table and the other thread which wants to access the same table has to wait until the thread 1 finishes its execution with that table, right? That is what synchronization means. If it is not synchronized, then two threads, that is thread 1 and thread 2, both can access that particular table at the same time. Hence, that is one of the biggest differences between hash table and hash maps guys. Hash maps, the threads are not synchronized. Hash tables, threads are synchronized. That is the second difference between hash tables and hash maps. I hope you remember this guys. Next, it is really good for search operations as we have already looked at for hash tables. Based on the hash keys, I can directly get whatever value I want for that particular key. So we will continue with a diagram. I'll show you a diagram now. So I hope you understand this hash maps a little better with the diagram guys. Alright, so you can see the diagram here guys. I hope you are able to see this diagram. Now you can see the first line here which is written as map, right? Map, and then within the angular brackets we have written it as string comma integer. What it basically means is within that map, now map is an interface guys, right? It is not a class, it is an interface for which in this case we have created a reference called HM, right? So I will tell you in this particular line in detail when we talk about the program a little later in this particular video. So before that, just remember map is just an interface, it's not a class. for which we are trying to store in this particular map, hash map. We're going to try to store a data called as, we are going to store a string key comma integer value. So we are going to store a key which is of type string and a value which is of type integer into my hash maps. That right side, when you write new hash map, it actually creates a object with that particular map. Now you can see, whenever I want to enter some key value pairs into my hash map, then I will use a function called put. So you can see here, it is written here as hm.put. hm is your object of hash map, and then we are calling a function called put function, which is basically used for entering the value key and value pair into my table, right, hash map table. So in this case, I am entering ABC as my key, 100 is my value, BCA as my key, 101 as the value, AAA as my key, and 102 as my value. So in this case, we are entering 3 key value pairs. Next, you can see on the bottom, remember, whenever we talk about a put function, it will have 2 parameters. One is your key, second is your value. That is what we can see here at the bottom, guys. Next, whenever we talk about hash maps, the main advantage of having a hash map is, whenever you want to search a value, it is very, very fast and very quick. The reason is because, remember, whatever, for example, in this case, we have given a key called ABC. Now, this ABC will have to be converted into an equivalent hash code, guys. There will be a hash function which will automatically convert my ABC key into a hash code. As you can see there, I have written it as hash code is equal to hash of ABC. For example, that hash code will be in terms of an integer value. It's just an example, guys. It is there are 7 ones and 2. That is the hash code that has been generated for the key ABC, and which is going to be stored in the hash code. Now, this hash code again needs to be converted into something called as a index value. Whenever you create a hash map, an array will be created with index values. Now, the size of your hash map by default is going to be 16, right? That is the reason on the right hand side you can see the diagram. It consists of values, index values 0 to 15. That is, the size of my table is, or my array is 16, right? That is the initial default size. Now I can change the size. I will tell you how to change it with the different constructors that are there as part of your hash maps, right? So remember that hash code is nothing but the code which is generated for your key, and then that hash code has to be again in turn converted into something called as an index value. At that particular index value, you see that yellow box there, it is called, whatever you see in that particular array, they are called as buckets. Each of them are called as buckets, right? Each of these buckets can contain hash code. It will contain a hash code, it will contain a key, it will contain a value, and it will contain the address of the next node, right? So remember, your key, value, and the hash code will be stored in these buckets. So by default, whenever your key has been converted to an equivalent index value, it will go to that index value, and in that index value it will store the hash code for that key, it will store the key itself, and it will store the value. Now, why do you think we have one more field called as address there? Now, the reason we have address there is because normally if you have only one key for that, a hash code for that particular key, then only one particular node will be created and that address will be null. Now, what if you create keys with 2 keys with the same hash code? Now in that case, whenever you create 2 keys with the same hash code, then these buckets will be containing something called as linked list. Okay, so the same index value, for example, one is the index value for 2 different keys, right? So the value for that particular key will be stored in the same index value. That means in one, for example, it will be stored your hash code, key, and the value. And remember, if you have another value that needs to be stored for that particular key, then it will just point an address to the next node in that particular list. So the buckets will act like linked lists, guys. So that is how your hash map actually works like, or it looks like also. We will continue with the slides now, guys. Alright, next we will be looking at something called as constructors in your hash maps. So you already know in hash tables we had 4 constructors. Similar to that, we have 4 constructors in hash maps also. So whenever you want to create a hash map, you have to write the name hash map as the class name, right? And then you can use a variable, you have to create an object. So in this case, I have created an object called h, right? You can see here. And then we have something called as, we have written here as new hash map, which basically allocates the memory for my object called h, which has been created for my hash map. So basically it will create a blank hash map, okay, or basically it's an array with index values 0 to 15. So there will be values, index values from 0 to 15. That is the size of my hash map will be 16 initially. And one more very important thing you can see here is the fill ratio of my hash map by default is 0.75. That means 75% of my hash map can be filled at that particular time by default, right? That means out of 16, 12 fields can be filled. After the 12th field, it will again take 16 more fields, guys, right? So this is very, very important for interviews. So make sure you remember this. Whenever I talk about hash maps, it will create a default size of an array which is 16, the size is 16, okay, and the fill ratio by default is 0.75, which is 75%. Now the range of the fill ratio ranges from 0 to 1.0, that is 0 being 0%, 1 being 100%, right? So in this case 75% is by default. So in this case, when you have a size of 16, 12 fields can be, or 12 buckets can be used. Okay, so that is what it means. Next, the second constructor, we have something called as initial capacity. Now this initial capacity basically tells that I want to change the initial capacity of my hash map. Initially, remember I just now told you, the size of my hash map initially is 16. Now I can change that size to whatever I want initially. So in this case, if I want to change the initial capacity to 20, I can mention in my second constructor, if I use the second constructor, I can mention there as 20 as my initial capacity, right? But the fill ratio will remain the same in the second constructor. Next, we have a third constructor where you can specify the capacity, right, in terms of integer, and we can also specify a fill ratio in terms of float. Now I told you the fill ratio by default here is 0.75, which can be changed to 0.80, 0.90 depending on your requirement. So the third constructor, you can give both the capacity as well as the fill ratio. Next, we have another constructor called hash map with your parameter called as map. So basically what happens is every map object, so for example we have hash table, we have tree maps, right? So these hash tables and tree maps can be automatically interchanged into something called as hash maps by using the fourth constructor. So we will continue with the next slide, guys. So you can see here in this slide, guys, we have already seen your hash map will store in terms of keys and value pairs, right, just like your hash tables. And whatever I've explained using that diagram is written in the notes here. So whenever you are using a hash map, you have to specify an object. That object is used as a key, and the value that you want to be linked can be given to that particular key. The key is then hashed using a hash function, okay, and that resulting hash code has to be converted back to something called as an index value, so that I can store in my array. Right? So that is what the second point is saying. Third point is basically it is showing the signature of how you have to create a class. You have to write class, hash map is my name of the class, and within that K is my key and V is my value that I want to store for that particular key. Now next we are going to look at something called as a program on this particular hash map, guys. So listen very, very carefully. It is very interesting, very important. So please make sure you listen to this very, very carefully, guys. So we'll start off, guys. As you already know, the name of my program is Hashmap Demo, and the class I have used is also Hashmap Demo, guys. And the package that I am importing into my program is called as java.util.star. So util is the package which is used. Remember, this map and your hashmap class and your map interface, it has to be recognized. Then we have to import the classes within my util package, right? So that is the reason I have written this, and I have written my program within the package collection, guys. Now within my class called hash demo, I have created a function called main. Within this main function, initially I have written as map. Now map is an interface, guys. For maps I cannot create objects. If you remember what an interface means, I cannot create any objects for my interfaces, but I can create something called as references. So you can see here I have created a reference called HM, okay, and this HM is an object of type hash map, right? So when I create a hash map, remember the initial size of my hash map is 16. 16 is the initial size of my hash map, and the field ratio by default initially is 0.75%. Now in this case, in this program, we are storing string and integer values, guys, right? Just a second, guys. So in this program, we are storing a string key and we are storing a integer value for that particular key. So your keys are of type strings and integer are of type or basically values for that particular key. So this line will basically create an empty map, right? It will create an empty map with the size 16 as my array. Next, we are using this hm.put function to enter the values key and value pairs into my array which has been created, empty hash map which has been created. So in this case, I have created Amit as the key, 100 as the value, Sachin as the key, 101 as the value, Amog as the key, 103 as the value, Rahul as the key, and 104 as the value. So in this case, now I have stored 4 key value pairs into my hash maps, right? So in this case, remember, again I will repeat it, this Amit is the key which has to be converted to an equivalent hash code, and that hash code, using a hash function, it will be converted to a hash code, and this hash code in turn has to be converted to an equivalent index value. So this Amit will basically be stored in some random some index value which has been given created by that hash function, guys. So for that, basically it will out of those 16, that is 0 to 16 size of my hash map, at one of those index values this key and value will be stored. Later in this particular video, I will show you how it exactly gets stored, guys, right? So in this case, I have created 4 key value pairs and I have stored it into the hash map. Next, I already told you that we can make or create something called as a null key. So remember, whenever I create a null key, by default, the 0th index value will be stored as a null key and the value. So in this case, I have stored using a put function, I am storing the key as null and the value as 106. So by default, it will take the 0th index value in my hash map or the array. Next, we are using another put function for, this line is there to basically show you that you can have duplicate keys. You can see here, I already have a Rahul key with a value called 104. Again, I am creating a Rahul key with a different value called 108. Now what will happen? Basically what happens here is, again, Rahul also will have a same hash value, right, or the same index value it will be pointing to. So at that value where 104 was stored at that index value, there what will happen is it will get replaced, the 104 will just get replaced with this value called 108, right? It will not create a new key called Rahul, but it will just replace this particular 104 with 108. That is what it means. Next, I wanted to show you that you can never, basically this line tells you that you cannot have null keys and null values, guys, right? So remember, whenever we talk about this, we cannot have null values. So in this case, you can see that when I try to run this program, it will actually give an error called as null pointer exception, because already remember here I have written as null, so I cannot have duplicate null values, guys. I'm sorry, for some reason it has been written as compute here. Just a second, guys. So basically this particular line will give you a null pointer exception, guys. Okay, so you cannot have multiple null keys. That is the reason I wanted to show you this, right? So obviously it will not give you a compile time error, it will show you a runtime error. That is the reason I have commented this, guys. Next, I will be sharing this program and the PPTs with you. Do not worry, write down in the description, guys, so you can check it out later. Next, I have created 2 string values, guys. Now why I have created these 2 string values is because I wanted to show you that if you have 2 strings or 2 keys with the same hash code, what exactly happens, right? That is what I wanted to show you. So basically I have created a string called S1, string object called S1, which contains FB as my string, and a string S2 contains something called as EA. Now when I want to print the hash code for both of these, remember the hash code for this particular FB string and EA string are actually same, right? So in my case, when I run the program, the hash code, if you want to print, you have to use the string object, that is S1, and I have to call the function called hash code. So basically this will return the hash code which has been applied for this particular string, or in this case it is my key, right? So basically in my case it returns 2236 as my hash code, and same happens to this S2 object also. Basically both S1 and S2 keys will have the same hash code, that is 2236, right? Next I have again created another map, again same thing as the previous one, but with a different object name, that is HM2, right? Next, instead of you writing these values, string values directly, I am writing S1, and the value for that S1 string, that is FB, is my S1, and for that I am storing the value 1, and then for S2 my key is EA, and for which I am storing the value 2, right? So what will happen basically here is it will store this S1 or FB into my array table. Okay, so listen very carefully now. In my array table, remember the key for the FB is basically the hash code that has been generated is 2236, and for example we will assume that has been converted to an index value called 4, right, for FB. For this S1, just assume that the index value where this key is getting stored is at the array index value 4. Now when I talk about, then obviously at that index value 4, the hash code, the key, the value will be stored at that particular index value. Now when I go to the S2 part, now you can see here when I talk about S2 again, now this S2 also will generate the same hash code. So what will happen now here is it will again refer to that 4th index value in my array, but in this case it will basically, what will happen is it will create a linked list now. So the S1 which is containing FB will now point to the second list which will contain the S2 with the key EA and the value 2. So it will, at the same index value 4 of my array, it will create a linked list now. That is what happens when I talk about these two values being put into my hash map. So basically in this case I am just writing a title here saying that hash map, the first hash map is getting printed. So basically this is the for loop which is being used for printing my hash map, right? So you can see here at the top, the thing is I have already entered so many different values, key value pair into my hash maps. So to print them I am using a for loop here. Now this map is an interface, okay, and this entry is interface within my map interface. So it is called entry is a nested interface, right? So basically this map contains an entry interface. Basically using this map entry, I can access whatever is there in the set. So basically whatever is there in my hash map will be getting converted into something called as a set. So all the key value pairs are converted to something called as a set, guys. So using this entry set, I am basically using this object called HM, I will be accessing the entry set which contains my key value pairs in my map, right? So basically using this map entry object called M, I am going to access the entry set. So that is what it means. So in this case I am just printing now using this, so what we are saying is map entry object M is going to access the entry set, and I am going to get the key and the value from that particular entry set. So in this case the key will be random, I mean obviously based on the hash code it will go to that index value and it will get the particular key and the value for that particular key and print there, right? So the next for loop is used for another hash map that I have created here to show you that if two keys are having the same hash code, then what will happen. So that is what is done here also. It's the same as the same similar to this particular for loop itself. Here also we are basically printing the key and the value for my hash map. So I will also run this program once and show you how the output looks like, guys. Just a second. Alright, as you can see here, guys, in this particular output, the first thing is we are just printing the two keys are having the same hash code. That is what we are printing initially. So you can see here I have written here as system.out.println s1.hashcode s2.hashcode. Remember I told you by default or basically both these strings are generating the same hash code, guys, right? So that is the reason we are just trying to print the hash code for both the strings. So in this case both are having the hash codes 2236, right? Next we are going to print the complete hash map. So initially the hash map is containing these values, key value pairs, Amit, Sachin, Amog, Rahul and null, right? That is what is going to get printed here, guys. So in this first for loop, when we look at this first for loop here, now this is what the output will look like. So initially null is getting printed with the value of 106, Rahul, Amog, Amit and Sachin. Next, finally, we have, remember I told you that this FB1, that is nothing but this FB and EA are also getting stored. But in this case, we are telling that because the hash code is same for both these string keys, right, they will be stored at the same index value, right. So that is what is getting printed with the second for loop, guys. We are just basically printing the values which are there in the second hash map. Now I just want to debug this program and show how this program actually works, guys. Just a second, guys. So please look at this diagram, guys, or basically it's a window which could not be captured in the software, so I have separately kept it aside. So you can see this, whenever I am executing this particular program, you can see that the size here has been created as 16, right? So hash map node, remember whenever you create a hash map, it creates an array, each of them is called as a node or bucket, guys, right? So it's saying that it contains k and comma v, key and value, 16 is the initial size of it, right? It does not mention, in this case it is not mentioning that it is fill ratio is 75% or 0.75, but it is by initially 0.75, guys, right? Next we can see here, guys, at the index value 0, right, a particular key value pair is being stored. At index value 1, a key value pair is being stored. At 3, 8 and 15 similarly. So you can see here that we have an index value from 0 to 15, that is the size of my hash map is 16 by default. So I told you whenever I have a key which is null, by default it will get stored in the index value 0. All the other keys which have been generated will get some other index values. But remember, when there are 2 or 3, more than one key having the same hash code, then it will create at that particular bucket or in that particular index value, it will create a linked list. So please remember these things, guys. I hope you have understood what hash maps are. I hope you, if you have any questions, you can always get back to me, guys, and please ping me whenever you have any questions. I hope you have enjoyed this session. I know I have told you a lot of things. Please do go through this video again. Again, I will be sharing all the PPTs and the program in my description. Please do like the video and subscribe for it because I am making a lot of videos, right? So please make sure, if you subscribe, you will always get a notification saying the program, if I have uploaded a video, you will get a subscription notification in your, in your phone or laptop or wherever it is, right? So please do watch, stay tuned, guys. I will come back with another video a little later. Thank you.